Okay, so now the faces, we know from our shape without the hole in it that there are 12.
So these are pretty easy. There's 6 faces, 1, 2, 3, 4, 5, 6 that aren't part of the second shape, that are part of the first shape.
Put it down here.
And then there are 6 of these L-shaped faces
So put it down.
that are part of it. Like those L's.
Okay.
And then, so it's just 12 minus 6 plus 6.
12 minus 6 plus 6. Okay, so how can we count can you count the 6 and 6 also?
So we have,
See if you can do it without moving the cube around.
right, so it's 1, 2, 3, and then it's the same thing on the other side. So
Okay, so there's some symmetry there.
and then there's 1, 2, 3, and then there's the same thing on the other side.
Okay.
The ones you have to subtract first, and then we added in the other ones.
Okay, so now I want you to count the faces that we need to subtract and add in, but relate them to the big cube.
Well,
That's what I'm looking for you
So-
guys to see here.
each we need to the ones that we subtract and the ones that we add in, the L and then the smaller square, they make up one face of the cube.
Ah,
And then, so they cancel, they sort of cancel out, and then you do that all over.
okay, do you see that too?
Yeah.
Alright. Okay, very good. So it's interesting that the idea that these two shapes come together to form a cube actually helps us see that the a reasonably easy way to relate the vertices, edges, and faces of the two shapes. And I think this is a little bit easier. Obviously, that's not always going to happen, but I think this is a little bit easier than trying to count the vertices, edges, and faces of this shape all by itself, which really gave us a hard time.
Yeah.
All right, good work this morning, guys.